Hello, Mr. Gasta here, homework 584. Here we go. In the box, write out the statement that shows the relationship. So for instance, as sediment size increases, the water retention decreases. You want to write the words out. Then you're going to sketch a line graph to show the relationship. Okay, too many kids do the graphs first. They just seem to kind of guess. The words are the most important part. Either write it down, get it in your head. This is helping you do that. So, you got to look here. Sediment size and how that affects permeability rate. This always affects this, so start with this. And you could say something fairly simple as the bigger the sediment, okay, permeability rate. Rate is like speed, how fast the water goes through. That's what permeability is, water flowing through. And then you need to know the fact of the bigger the sediment, you're going to have a higher permeability rate. It's going to go faster. So the bigger the sediment, you could say something just like the faster the permeability rate. That is the relationship. Now, you want to see what the graph is. So as sediment size smaller to larger, how does that affect rate? And the graph is going to look like this, okay? And you want to check smaller sediments, lower rate, lower speed, bigger sediment, higher speed, okay? And so you always want to do that. That will really help. B, sediment size, rounded, rounded and sorted, that's key, versus porosity. Porosity is how much empty space there is in the in between the sediments. So you could say, and this is one thing you can say, the bigger the sediment, okay, as the sediment gets bigger, how does that affect porosity? The key thing, rounded and sorted, this is the key thing you need to know. If it is really rounded and sorted within your container or sample, whatever you have, the porosity stays the same, okay, and that's hard for a lot of students. The bigger the sediment, something just like the porosity stays the same, okay? And what would that graph look like? Hopefully you can get that in your brain. Porosity will stay the same regardless of the size, and it should go like that. Alright, that's B. Now, C looks like this. Okay, moisture versus chemical weathering. So you need to know the relationship, and basically the more moisture in the air, the more rainfall and the climate, whatever it may be, the more moisture, the more chemical weathering. Water is a main agent of the main agent of chemical weathering. So the more water there is, the more reactions there will be. Then know that relationship, and then the graph is going to look like this. This is going to be a little moisture, a lot of moisture. The graph will go up. Okay, and you can check. I have a little bit of moisture, I will have a little bit of chemical weathering. If I have a lot of moisture, I'll have a lot of chemical weathering. Always do that. Always do that. Don't just be writing up, down. I think sometimes people just kind of randomly guess. This is not about guessing. It's about knowing these things. D is this one. Sediment size, water retention. And you can say as sediment size increases, let's say. You could say that. Or as sediment size gets, as sediment gets bigger. As sediment size maybe increases. I do arrow up sometimes. I like that. You could use the word increases, whatever works for you. As sediment size increases, how does that affect water retention? Water retention is the water that stays trapped within the sediments after it's been drained. And hopefully you know that relationship is the smaller the sediment, the more water retention there will be. So as sediment size increases, water retention will decrease. There'll be less of it. So larger sediments will have less water retention. Write that out and then really apply it to here. Again, small sediment size, larger. It should look like this. Okay? And then that just says the small sediment size will have a high water retention. Large sediments, let's say pebbles or something, is going to have much less water retention. Okay? That's key. Let's go on to the back. This one here, it asks this question. Here's the hydrological cycle. And which numbered arrow best represents the process of transpiration? Transpiration, know it, is water vapor given off by plants and trees, plant life. And that answer here is, that says represents 1 point. The answer is 1. This right here is shows transpiration. Know that. And then we have other things. I'm going to say 6 is runoff. These arrows right here not labeled as infiltration, water going into the ground, precipitation, evaporation at 8. Okay. Those are just some of the things there. Now, for these right here. Base your answers to questions 24 through 27 on the diagram below. Columns A, B, C, and D are partially filled with different sediments. Within each column, the sediment is uniform in size. Uniform means it's all the same, so that means it's really well sorted. A fine wire mesh screen covers the bottom of each column to prevent the sediment from falling out. The lower part of each column has just been placed in a beaker full of water. Sediment sizes are not drawn to scale. Okay. So in this case, it has it resting in some water. It's going to test capillarity, how far up it's going to move. But we just talk about the sediment size here and try to apply it to these questions here. So hopefully you can see large silt, large sand, small pebbles, medium sand. So this is the smallest sediment here. It's interesting, key to know. This would be second smallest, third smallest, and this is the largest here. So 24, using the column letters, put the columns in order of increasing permeability. Okay, a few things here. You need to know permeability is if water was flowing through it. If we had, took it out of the setup and poured water through. The faster it goes through, the higher the permeability. So this is where it messes people up. Increasing. Okay, that means from lowest to highest. So the lowest permeability does depend on size. The smallest one has the lowest permeability. Therefore, it would be something like D, and then A would be next, then C as they get bigger, C, and then B. Increasing smallest to largest. And these phrases here are where a lot of people just get tripped up. 25, using the column letters, put the columns in order of increasing capillarity. Capillarity is what they're testing here with the water moving upward. Increasing, again, means from least to the most. So capillarity is also a function of size of the sediment. The smaller the sediment, more capillarity. So if I'm going to do the lowest capillarity, it's going to be the largest sediment. So it's going to be B, and then large sand, which is C, then medium sand, A, and the highest capillarity would be column D, the smallest sediment. Okay, and then 26. Put the columns in order of decreasing water retention. After the water's gone through, water retention is how much water stays trapped within the sediments, on the surface of the sediments. Decreasing means from highest water retention to the lowest water retention. Get that in your brain. Take your time and go slow with it if you need to. So water retention, decreasing, highest to lowest. The highest water retention, the smaller the sediments, the more water retention. Therefore, this is going to be first D, and then the next one is going to be medium sand, D, A, and then large sand, and then the largest one, the small pebbles, will be last. That will have the least water retention. I really have to take my time and think about it as well. Everyone does. It just doesn't jump out at you. Here's another one. Put the columns in order of decreasing infiltration time. Water going through time. It's kind of opposite of permeability. Permeability, speed, infiltration, time. So the slower it goes through, the more time it will take. Okay? And high permeability, when water flows through very fast, it takes the least amount of time. And that is also very tricky. So decreasing means from highest to lowest. The highest time of water to infiltrate or go through would be the smallest sediment. So this is going to be first. D. And then it's going to be A, the next size up. And then it's going to be large sand, C. And then it's going to be the lowest infiltration time, well, even I have to think about it, will be B. Okay? So hopefully that helped. That is homework 584. for all of us here, Gazzoni Productions, thank you for watching.